Now we will solve problem on the Fourier transform by using properties. There are 4 problems are given. First is x of t is equal to e raised to at u of minus t, and other problems are there. Here you need not to solve these problem using Fourier transform formula. So here directly you have to apply the Fourier transform properties and the Fourier transform the basic signal. So within 2 to 3 steps you will get answer of the any question. So your problem will made more simpler by using the properties. Let us take first problem, that is x of t is equal to e raised to at u of minus t. So if you look at this signal, so this signal is a time reversal signal of the x of t, that let this x1 of t is equal to e raised to minus at and u of this, the t will be there. So exactly this is x of t is equal to x1 of minus t, the time reversal signal. So you can apply the time reversal properties. So therefore the Fourier transform of x1 of t, that already we know, e raised to minus at u of t is equal to 1 upon a plus j omega. Now the time reversal property states that by using time reversal property, that is the x of t, x of minus t is a Fourier pair of x of minus j omega. If Fourier transform of x of t is x of j omega, Fourier transform of the x of minus t is x of minus j omega. So therefore x1 of t is equal to x of t is equal to x1 of minus t, that is the time reversal property. Therefore you can write Fourier transform of the x of t, which is equal to x1 of minus t, that is the time reversal property. So this is equal to x1 of minus j omega. So x1 of j omega, this is equal to x1 of j omega, and x1 of minus j omega means wherever the omega is there, you replace the omega by minus. Therefore the Fourier transform of this x of t is equal to 1 upon a minus j omega. It's so simple. So just you use Fourier transform of the basic signal, then you write the property, apply the property, so you will get the answer very easily. Now we will solve Fourier transform problems by using properties. For that you should know Fourier transform of basic signals and the properties. By making use of the properties and the basic signal, you can find out Fourier transform of any complex signal. So within 2 to 3 steps you will get answer. No need to solve the problem by using the complete formula and all. Okay. Now let us see the problem. The first problem is that x of t is equal to e raised to at u of minus t. So if you look this problem, e raised to at u of minus t, so this is the time reversal signal of e raised to minus at u of t. So already we know the Fourier transform of e raised to minus at u of t. So you can write x1 of t is equal to e raised to minus at u of t. So the Fourier transform of this we know already, x1 of j omega is equal to 1 upon a plus j omega. Now x1 of t is equal to, if you look x1 of t and the relation between this x of t, x1 of t is equal to e raised to minus at u of t. So x1 of minus t, so just if you take the time reversal in the time domain, so it is nothing but u of minus t. It is a time reversal signal. So therefore x of t is equal to x1 of minus t, and we know the Fourier transform of x1 of the t is x1 of the j omega, and Fourier transform of x1 of minus t is equal to x1 of minus j omega. This is a time reversal property. So therefore wherever the omega is there in the x1 of j omega, you replace omega by minus omega, that will give you the Fourier transform of the x1 of minus t, which is equal to x of t. Therefore the Fourier transform of x of t is equal to you apply the time reversal property to this, that 1 upon a plus j omega, replace omega by minus omega, this is equal to 1 upon a minus j omega. So it's just so simple, no need to use any integration. The next problem is x of t is equal to t into e raised to minus at u of t. So if you look at this problem, you will see that so e raised to minus at u of t is a common signal, and that signal is multiplied by t in the time domain, so that is this t. So if you recall the properties, you will come to know that when the signal is multiplied by t in the time domain, it is equivalent to differentiation in the frequency domain. So that property I can write as the t into x of t, so its Fourier transform is equal to j into t upon d omega into x of the j omega. Okay, where you can look at this, so you can write, so from this problem x of t you can write equal to e raised to minus at u of t. So x of j omega, already we know the Fourier transform of this is equal to 1 upon a plus j omega. Therefore Fourier transform of this t into x of t is e raised to minus at that u of t. So this is equal to j into d upon the d omega into x of j omega. So this I will write the j into d upon d omega 1 upon a plus j omega. Now you can apply the differentiation of 1 upon x, which is equal to minus 1 upon x square. So this is equal to j into minus 1 upon a plus minus 1 square into the differentiation of this with respect to omega, so that is a j. Here the j is a j square is equal to minus 1 into minus 1 is a plus 1. So therefore, so this is coming out to be 1 upon a plus j omega square. So therefore, Fourier transform of this x of t into e raised to minus at u of t is equal to 1 upon a plus j omega square. X of t is equal to e raised to j omega 0 t u of t. There are two terms, one is u of t, another is e raised to j omega 0 t. It means another signal is multiplied by e raised to j omega 0 t to u of t. So you can use that property, which is a frequency shifting property. So we have to recall the properties. Fourier transform of u of t is equal to pi into del omega plus 1 upon j omega. So when the signal is multiplied by e raised to this the j omega 0 t in the time domain, so it is equivalent to its Fourier transform of x of the omega minus your omega 0. So wherever omega is there, you replace by the omega minus omega 0. This is equal to pi into del of omega minus omega 0 plus 1 upon j into omega minus omega 0. This is the Fourier transform of e raised to j omega 0 t u of t. Next problem is the cos omega 0 t u of t. Here we can use the same property. We know the Fourier transform of the u of t. This is equal to pi into del of omega plus 1 upon j omega. Now we know cos omega 0 t is equal to e raised to j omega 0 t plus e raised to minus j omega 0 t divided by 2. So you can use the same property. So accordingly I can write, so this equation is Fourier transform of this cos omega 0 t into u of t is equal to, it is 1 upon 2 into Fourier transform of e raised to j omega 0 t into u of t plus e raised to minus j omega 0 t into u of t. So already here we have seen Fourier transform of e raised to j omega 0 t u of t is this. So accordingly we can write, so this is equal to 1 upon 2 in bracket. So it is multiplied by e raised to j omega 0 t. You use the frequency shifting property. So this is equal to pi into del of omega minus omega 0 plus 1 upon j into omega minus omega 0 plus, here it is a minus, so it will become pi of del of omega plus omega 0 plus 1 upon j omega plus omega 0. This is Fourier transform of cos omega 0 t u of t. Similarly, you can find out the Fourier transform of the sine omega 0 t u of t. Only remember, Fourier transform only cos omega 0 t is different, and Fourier transform of the cos omega 0 t and u of t is different. Next problem is x of t is equal to d by dt of 2t into e raised to minus 2t u of t. So here if you look at this signal, so it is one signal e raised to minus 2t u of t, and this signal is multiplied by the t. So you can use this property which is called the differentiation in the frequency domain. So another, this is a differentiation of this signal. So again you have to use the differentiation property. So you have to use two properties. One is if the signal is multiplied in the time domain by t, that is a differentiation in frequency domain property, and differentiation in the time domain, that is equal to multiplying the signal equivalent to j omega, that we will see. Now let us write the Fourier transform of e raised to minus 2t u of t is equal to 1 upon 2 plus the j omega. That we know. Already it is a basic signal, you can write. Now you can write the property, if the signal is multiplied by t into x of t in the time domain, so its Fourier transform is, if the signal is multiplied by t in the time domain, it is equal to j into d by d omega of x of j omega. Now this is your x of j omega. So you can write Fourier transform of 2t into e raised to minus 2t into u of t. This is equal to 2 is a constant. Here I will take it as it is, into j into d upon the d omega into x of j omega is this. So this is 1 upon 2 plus the j omega. So this is equal to 2g, it is minus 1 upon x. 1 upon x, its derivative is minus 1 upon x square, 2 plus j omega square into derivative of this, it is j. So j square is a minus 1 into minus 1 is a plus 1. So this is equal to 2 upon 2 plus j omega square. Now third property is the d by dt of this signal. We know the derivative of the d by dt of x of t is equal to j omega into x of this j omega. Now this is x of j omega. So therefore derivative of this, so total Fourier transform of this signal is equal to, when you are taking the differentiation, just you have to add this j omega to the Fourier transform of this signal. So Fourier transform of this signal is 2 upon 2 plus j omega square. So it is equal to 2 into j omega divided by 2 plus j omega square. It is the Fourier transform of this signal. The next problem is y of t is equal to d by dt of t into e raised to minus 3t u of t convolved with e raised to minus 2t u of t. So if you look here, this is a one signal, this is second signal, these two signals are convolved. So you can use the convolution property. And here it is a d by dt, means total you have to use the convolution plus d by dt properties. So you know the Fourier transform of x1 of t convolved with x2 of t. So this is equal to x1 of j omega into x2 of j omega. That means when the two signals are convolved in the time domain, its Fourier transform is a multiplication of its Fourier transform. And another property d by dt, so that d by dt of x of t, so this is its Fourier transform is j omega into x of j omega. So we have to use these two properties. So here again, but here once again it is multiplied by t. You have to use that property also, that t into x of t, if the signal is multiplied in the time domain, its Fourier transform is equal to j into d upon d omega into x of j omega. So we have to use these three properties. You use this is first property, this is the second property, and the third property. First you specify. Now we will see it's the t into e raised to minus 3t u of t. So the Fourier transform of e raised to minus 3t into u of t. So this we have seen already. E raised to minus 8 u of t is 1 upon a plus j omega. That is 1 upon 3 plus j omega. When the signal is multiplied by the t, so that Fourier transform of this t into e raised to minus 3t u of t. Okay, this is equal to 1 upon 3 plus j omega square. This also already we have seen. It is a Fourier transform of this first signal. Fourier transform of the second signal, that e raised to minus 2t into u of t is equal to 1 upon 2 plus j omega. Now the Fourier transform of this whole signal is the multiplication of this x1 of j omega and this is x2 of j omega. And its derivative means it is multiplied by the j omega. So this you can write whole the y of the j omega is equal to, when you are taking derivative, it means you are multiplying in the frequency domain by j omega. And Fourier transform of this convolution in the time domain is a multiplication in the frequency domain. Its Fourier transform into this Fourier transform. So Fourier transform of this is equal to 1 upon 3 plus j omega square. Okay. Into Fourier transform of this is 1 upon 2 plus j omega. So you can write into 2 plus j omega. So it is a whole Fourier transform of this signal. Just we are using the property. You have to use three property. Accordingly, you can find out the Fourier transform of any complex signal. Now we will find out the Fourier transform of periodic signal. I told you Fourier transform is used only for the aperiodic signal. If there is a periodic signal, so you convert that periodic signal by using exponential periodic signal. So you can represent using x of t, that may be called as a aperiodic signal. So if you look at this x of t, these are nothing but a train of impulse signal. This is called as a train of impulse. It is called as train of impulse. Impulse is nothing but del of t. Okay, so this is a del of t minus capital T, del of t minus 2t, it is a delayed, and these are advanced signal, and this signal is also called as the comp signal. That is a comp t. T is a period of t is equal to summation n is equal to minus infinity to infinity del of t minus nt, where n goes from the minus infinity to infinity. So if it is 1, t minus capital T means it is this signal, t minus 2t is this pulse, t minus 3t. So it is addition of all this signal. So this train of impulses is represented by this signal. Okay, and this is a periodic signal. So if it is a periodic signal, we have to find out Fourier transform of the periodic signal. The Fourier transform of the periodic signal is given by the x of j omega is equal to 2 pi into summation n is equal to minus infinity to infinity Cn del of omega minus n omega 0, where the Cn is Fourier series coefficient, that is equal to 1 upon capital T 0 to t x of t e raised to minus j n omega 0 t into dt. Just you have to use the simple formula. So from this you will come to know that the period of the signal is equal to t. So we will find out the Cn. So this Cn is equal to 1 upon capital T and integration for the one period x of t is here the del of t into e raised to minus j n omega 0 t into dt. Now we have seen del of t is an impulse function which is present only at the t is equal to 0. So we substitute t is equal to 0 into this. So this is equal to 1 upon t 0 to t del of t into dt. So area under the curve of the impulse function is equal to 1. So therefore the Cn is coming out to be only 1 upon t. So you substitute the values of the Cn into this equation, that is a Fourier transform of the periodic signal. So x of j omega is equal to 2 pi summation n is equal to minus infinity to infinity into Cn, which is equal to 1 upon capital T into del of omega minus n omega 0. So this is nothing but it is 2 pi upon capital T into summation n is equal to minus infinity to infinity into del of omega minus n omega 0. This is x of j omega. This is also nothing but this signal is a train of impulses in the frequency domain. So accordingly, you can write, if you want to sketch this signal, so this signal will be again the train of impulses. This is omega, this is x of j omega, this is 0, it is 2 pi upon capital T, it is 4 pi upon capital T, 6 pi upon capital T, minus 2 pi upon capital T, and so on. So, and this you can also call it as a com of this T and j omega. It is nothing but. So, this is a Fourier transform of train of impulse function.